Hello there. Thanks for joining us today. It is great to meet you. To get us started, I have had a look at your portfolio and your background, and it looks like you have a solid foundation. We are looking for someone who can jump into our pipeline and handle junior to mid-level tasks with a good amount of independence. How are you doing today?
I am doing great, thank you. I really appreciate the opportunity to speak with you. I have been following the work your studio has been doing for a while now, and I am excited to see if my skills are a good fit for the team.
Glad to hear it. Let us jump right in. I want to start with some of the fundamentals just to get a feel for how you approach your work. If you were explaining the core of your craft to someone, could you name 3 fundamental principles of animation and tell me how they actually function in a shot?
Sure, I would say the 3 most fundamental ones are squash and stretch, anticipation and timing. Squash and stretch is really about giving objects a sense of weight and flexibility. By deforming the model when it moves or collides with something, you avoid that rigid, robotic look and make the character feel more organic.
Right, and anticipation is the one that prepares the viewer, correct?
Exactly. Anticipation prepares the audience for an action by showing a small movement in the opposite direction first. For example, if a character is about to throw a ball, they don't just launch it, they wind up first. It signals to the viewer that something is about to happen, which makes the final action feel much more intentional and powerful.
And timing, that seems straightforward, but it is often where the most mistakes happen.
Definitely. Timing controls how fast or slow an action happens, and it directly affects how the movement feels to the audience. If an action is light and quick, it feels energetic or agile. If it is heavy and slow, it conveys mass and effort. If the timing is off by even a couple of frames, the whole physical presence of the character can change.
That is a good foundation. Let us move into some practical scenario work. Imagine you are handed a shot that requires a large crowd of background extras. You cannot possibly animate and render every single character individually without killing the render farm. How would you handle that pipeline efficiently?
For a large crowd, the key is to move away from manual animation and toward a more procedural approach. First, I would start by creating a library of pre-rigged and animated character models. I would make sure there are variations in clothing, body types, and a few different movement cycles, so the crowd doesn't look like a bunch of clones.
So you are building a modular kit first. What comes after that?
Once the library is set, I would use a crowd simulation tool to populate the scene. Instead of placing characters by hand, I would define their paths, general behaviors, and interactions procedurally. This lets the tool handle the distribution and the movement of the masses based on the rules I set.
And from a rendering standpoint, how do you stop the scene from becoming too heavy for the computer to handle?
That is where instancing or geometry caching comes in. I would use instancing so the renderer can reuse the same character model multiple times while applying slight variations. It drastically reduces the memory overhead and render times because the system isn't calculating unique geometry for every single extra. Finally, I would composite the rendered crowd into the final scene, adjusting the lighting and color to make sure they blend naturally with the environment.
That sounds like a professional workflow. Let us pivot to a specific characterization challenge. Suppose a client looks at a render and says, the character needs to look heavy and sluggish. They are not happy with the current energy. Which animation principles and weight distributions are you focusing on to fix that?
In that case, I would lean heavily into squash and stretch, timing and follow-through. Heavy characters move slower and require significantly more effort to start an action, or bring it to a stop. I would slow down the timing of the primary movements to emphasize that struggle against gravity.
Would you change the actual posing or just the timing?
I would definitely adjust the posing. I would ensure the weight is distributed lower in the body, perhaps giving them broader shoulders and a thicker torso to visually emphasize the mass. The movement should have delayed reactions, like a very slow rise after sitting down. I would also introduce exaggerated inertia, where the limbs drag slightly behind the main body.
You mentioned follow through. How does that play into the feeling of weight?
Overlapping action is huge here. Secondary parts, like a character's belly, loose clothing, or even just the soft tissue of the arms, should continue moving for a few frames after the main body has stopped. That lingering motion sells the idea that there is a lot of mass moving, and it cannot all stop instantly.
Let us talk about the technical side of things for a moment. We work in a very large team here, and version control can be a nightmare if not handled correctly. How do you manage asset version control in a large VFX pipeline?
I am used to using centralized systems to track changes and prevent conflicts. Typically, this involves software like Perforce or Git LFS, combined with very strict naming conventions and a structured folder hierarchy. I believe it is critical to have a system where every asset has a unique version number or a timestamp.
What about when two people are working on the same asset?
That is where branching strategies come in. We can isolate work in progress in separate branches, so we aren't overwriting each other's changes. I make it a habit to log every change with descriptive notes, so the rest of the team knows exactly what was updated. Regular backups and automated checks are also a must to maintain integrity. And of course, just using communication tools like Slack or ShotGrid to make sure everyone is aware of dependencies. I've found that the biggest issues usually come from a lack of communication, so keeping the logs updated is just as important as the software itself.
I'd agree. Now let us get a bit more technical. Imagine you have a key character running, but as they move, the animation seems to lose weight. The character looks like they are shrinking or collapsing in certain areas during the run. What technical aspect of the skeleton or mesh is likely causing this, and how do you resolve it?
That sounds like a skinning weights issue. Skinning weights determine how much influence each bone has on the vertices of the mesh. If the weights aren't properly distributed, the mesh can collapse or pinch when the bones move into extreme positions, which makes the character look like they are losing volume or weight.
Could it be something other than just weights?
It could be insufficient joint influence. If certain areas of the mesh aren't properly bound to the skeleton, you get unnatural stretching or compression. To fix this, I would go back into the software and paint the skinning weights more carefully, ensuring the transitions between bones are smooth.
If the weights are correct but the volume still looks a bit flat in the joints, what is your next step?
I would implement corrective blend shapes. These are specific mesh shapes that trigger when a joint reaches a certain angle. For example, when an elbow bends, a blend shape can push the mesh out to simulate a muscle bulging or prevent the joint from collapsing. It is the best way to maintain volume during extreme poses.
That is a solid answer. Let us broaden this. When a client gives vague feedback and says the weight feels off, without specifying what is wrong, where do you start? What three areas do you investigate first?
When feedback is that vague, I usually go back to the basics: timing, spacing, and follow-through. First, I check the timing. I ask myself if the action is taking the right amount of time to accelerate or decelerate. If a heavy object starts moving too quickly, it feels light.
And spacing. How is that different from timing?
Timing is the total time it takes to get from point A to point B, but spacing is how the character's parts move in relation to each other within that time. Heavier movements have more gradual changes in speed. Lighter movements are snappier and have more abrupt changes in spacing. If the spacing is too linear, the weight will feel fake.
And the third area was follow through.
Yes, I look at the secondary motion. If a character stops abruptly but their hair, clothes, or accessories stop at the exact same moment, the character will feel like a plastic statue. Adding that secondary motion helps sell the physical presence and the weight of the character in the environment.
Let us shift gears towards some more complex theoretical challenges. Imagine you are tasked with simulating biological decay or organic material breakdown. This is a slow process in real life, but you have to show it happening in a few seconds. What are the theoretical and technical challenges of doing that realistically in a constrained timeframe?
The biggest challenge is the compression of time. You are trying to fit months or years of chemical reactions and microbial activity into a few seconds. The hurdle is to do this without making it look like a cheap time lapse or something overly exaggerated. You have to accurately model the gradual breakdown of structures, like the softening of tissue, the shifting color palettes, and the degradation of textures.
That sounds like a heavy lift for a shader. How do you handle the interaction with the environment?
That is where it gets computationally expensive. Simulating how decaying matter interacts with moisture, insects, or fungi requires advanced physics and procedural systems. You cannot just animate a texture swap. You need to show the material actually breaking down. The balance is finding where to simplify the process and where to use high-fidelity simulations, so the audience is convinced without the render times exploding.
Speaking of artistic direction, we often deal with clients who want a highly stylized look. Maybe it's something that completely defies physics or reality. How do you guide the technical implementation of a stylized look while still respecting the artistic vision?
I think the first step is to break the stylized look down into its core visual elements. I would identify what is non-negotiable. Maybe it is the exaggerated proportions or a specific non-realistic lighting scheme, and what can be adjusted for the sake of the pipeline. I find it very helpful to bring in references from other films or games that have achieved a similar style to align expectations.
Do you change your toolset for stylized work?
I try to prioritize tools that allow for flexibility. For example, I would use procedural shading or highly customizable rigs. If the client decides halfway through that the characters should be more stretchy or the colors should shift, a procedural setup allows me to make those changes without having to rework every single shot from scratch. I also make it a point to share work-in-progress renders frequently, so the client can steer the direction before I commit too much time to a specific technical path.
Let us do a quick lightning round of some technical definitions to make sure we are on the same page. First, in the context of character animation, what is a rig?
A rig is essentially a digital skeleton or framework. It consists of bones, joints, and controls that allow an animator to manipulate the 3D model. Instead of moving individual vertices, the animator moves the controls, and the rig handles the movement of the mesh. It is like the strings on a puppet.
Good. Next, what is the function of a normal map?
A normal map is a texture that simulates detailed surface bumps and grooves without actually adding more polygons to the geometry. It stores direction information for each pixel, which tells the lighting engine how to bounce light off the surface to create the illusion of depth, like wrinkles or scratches, while keeping the model lightweight.
Perfect. Now let us talk lighting. What is the difference between volumetric lighting and simple area light sources, and when would you definitively choose one over the other?
Volumetric lighting simulates light interacting with particles in the air, which gives you those visible beams or shafts of light, like sunlight through fog or dust. It adds a lot of atmospheric depth because the light feels tangible. Simple area lights, on the other hand, emit light from a shape, like a rectangle, but they don't simulate the medium the light is traveling through.
So when is the area light the better choice?
Area lights are better for clean, stylized, or performance-heavy projects, where you just need consistent, soft illumination without the computational cost of volumes. If you are doing a brightly lit studio shot or a simple indoor cartoon scene, you don't need volumes. But if you want a moody sunrise in a forest or a hazy concert hall, volumetric lighting is superior because it creates that sense of place and mood.
Which type of lighting would you use specifically to separate a subject from a dark background?
I would use rim lighting. By placing the light behind or to the side of the subject, you create a thin outline of light along the edges. This defines the subject's silhouette and prevents them from blending into the background, which adds a lot of dimension to the shot.
Let us talk about particles. Walk me through your process for setting up a basic particle system to simulate smoke.
I would start by creating a particle emitter as the source. Then I would adjust the properties of the particles, specifically the size, lifespan, and velocity. For smoke, I want light particles that rise and then gradually dissipate over time. To make it look natural and not like a straight line, I would add forces like turbulence or a wind vector to create that drifting effect.
And for the look of the smoke itself,
I would apply a material or a shader using a semi-transparent texture with soft, blurred edges. The biggest challenge there is balancing the particle count. To keep it performant, I would use techniques like particle pooling or limit the number of active particles while using larger, softer sprites to fill the volume.
let us move into camera work. How do you achieve a cinematic bokeh effect or a depth of field in a CG render, and what data do you need from the camera?
To get that bokeh effect, you have to simulate how a real physical lens works. I need three main pieces of data: the aperture, the focal length, and the focus distance. The aperture controls the depth of field. A wider aperture creates a shallower focus and more blur in the out-of-focus areas. The focal length determines the magnification and field of view.
And how do you get the actual shape of the bokeh?
That depends on the render engine, but you can usually adjust the number and shape of the aperture blades. This allows you to create the polygonal bokeh highlights you see in real cinema. The engine then calculates the depth of every pixel and applies the blur based on how far that pixel is from the focus distance.
I want to touch on physics solvers. Can you compare and contrast Flip versus SPH for fluid simulations?
Both are used for fluids, but they have different strengths. Flip, or fluid implicit particle, is generally my go-to for large-scale stuff like ocean waves or waterfalls. It uses a hybrid grid particle approach, which makes it very stable and efficient for high-resolution surfaces and complex collisions.
Where does SPH fit in then?
SPH, or smoothed particle hydrodynamics, treats the fluid entirely as particles. This makes it much better for smaller-scale, intricate behaviors, like a glass of water splashing or highly viscous liquids. It is more flexible for irregular shapes, but it can be computationally heavier and less stable when you try to scale it up to a massive ocean. So Flip for scale, SPH for detailed, close-up fluid dynamics.
Let us talk about a concept called temporal coherence. What is that in the context of VFX, and why should an artist care about it?
Temporal coherence is basically the consistency of visual elements from one frame to the next. It ensures that things like fire, smoke, or water move smoothly without flickering, jittering, or jumping. The human eye is incredibly sensitive to these kinds of glitches. If a simulation has poor temporal coherence, it will look like there is a strobe effect or a glitch in the image, which immediately pulls the viewer out of the experience.
That's a common issue in simulations. How do you usually combat that?
It often comes down to the time step of the solver. If the time step is too large, the simulation can jump too far between frames, causing instability. By tightening the time step or using better interpolation, you can ensure that the motion is smooth across the sequence.
Interesting. Now let us talk about non-human entities. If you are animating an insect or a quadruped, what technical considerations are paramount that you wouldn't necessarily worry about with a human character?
With non-humans, the focus shifts heavily toward anatomy and biomechanics. For an insect, you are dealing with an exoskeleton and segmented body parts, which means the rigging has to account for plates that slide over each other rather than skin that stretches. For a quadruped, the center of mass is completely different, and the spine flexibility is a huge factor.
How does that affect the actual animation process?
You can't just apply human motion logic to them. An insect's weight is distributed very differently, and their movements are often more staccato or sudden. I spend a lot more time looking at reference footage of actual animals to understand how they shift their weight. Secondary motion is also different. For example, an insect's antennae or a dog's tail needs to be animated to enhance the realism of the primary movement without overpowering it.
On a related note, could you explain the difference between a solver and a simulation? I know some people use the terms interchangeably, but I want to see how you distinguish them.
I see the solver as the mathematical engine. It is the actual algorithm that calculates how a particle or a piece of cloth should behave based on rules like gravity, collision, and velocity. It takes the current state and calculates the next state.
And the simulation.
The simulation is the entire process of running that solver over a sequence of frames to generate the final motion. A simulation can actually use multiple solvers at once. For example, you might have one solver for the fluid and another for the collisions, and the simulation is the overall process that integrates them into a final animated result.
Last technical question for you. Can you define topology in character modeling and why it matters for the animator?
Topology is the arrangement and flow of the edges, vertices, and polygons on a 3D mesh. It is essentially the map of the model. For an animator, topology is everything because it determines how the mesh deforms. If the topology is poor, you get ugly pinching or stretching when a character moves their arm or smiles. Good topology follows the natural muscle and bone structures of the body, using clean edge loops to ensure the surface remains smooth during animation.
That covers the technical side of things quite well. I appreciate the detail in your answers. Before we wrap up, do you have any questions for us about the team or the projects you would be working on?
I do. I noticed in your recent reel that you are doing more complex character interactions with environments. I was wondering if the animation team is working closely with the FX team on those interactions, or if that is handled mostly in the simulation phase.
That is a great question. We actually have a very tight loop between animation and FX. Our animators often provide the base motion, but then they work with the FX artists to refine how the environment reacts to that motion. We try to avoid the silos where animation just hands off a file and hopes for the best.
That sounds like a great way to work. I have always found that the best results come from that kind of collaboration.
Absolutely. Well, we have covered a lot of ground today. I think I have a very good sense of where your skills are and how you approach problem solving. We will be reviewing all the candidates this week, and we'll get back to you shortly regarding the next steps.
Sounds great. Thank you for your time and for the conversation. I look forward to hearing from you.
You too. Have a great day.